So we now move on to the modulator, and we need to set the audio level from the microphone so that the modulator does its job, and similarly to the BFO. So what's the best level for the microphone signal? Well, if we look at the graph in the balanced modulator chip, which is the 1496, we see a few things here. One of them is we can set the carrier, for example the BFO, to give the best carrier suppression, and that happens to occur with a 10 meg output of the balanced modulator. In my case it's 9 meg, around about an input level of 160 millivolts RMS or 450 millivolts peak to peak. So they say to set the BFO at that level. And here we have a graph of input signal amplitude versus sideband harmonic suppression. And we notice that the input amplitude can be anything from 100 millivolts to 700 millivolts. And this particular graph shows the carrier level versus the signal input level. So here again we have the input signal going from 100 millivolts to 600. Here we have the output versus input signal level. So as the signal goes up and down, the output goes up and down. The carrier can go from 25 millivolts all the way up to 200 with very little change in output level. For example, if the signal input is sitting at 200 millivolts, the carrier can go from roughly 50 millivolts all the way up to 200 with virtually very small change in output amplitude, which is basically what you want. You don't want to be dependent on the carrier amplitude, you want to be dependent on the signal amplitude, which in this case in the balanced modulator is your microphone signal. So looking at their circuit of a typical application for a balanced modulator, they say here the carrier can be as low as 60 millivolts RMS. At the same time, the input signal can be anything up to, well, they recommend here around 300 millivolts. So here is my circuit: audio input and BFO input going into the chip on the appropriate pins, a balance control, and a relay which switches in a second balance control, which is used for AM, so that I can unbalance the modulator and use it on AM. I also have a secondary input which comes from an external sound source at the back of the transceiver. So it comes in here and bypasses the microphone preamp. So that will be at what we would normally call line level. I've got some figures here of 70 millivolts peak to peak, but they're early ones. I can actually change those numbers to a higher level, but it'll all depend on how much I want coming out of the balanced modulator to feed the stages further on. The output of the balanced modulator is actually tuned to 9 megs with this tuned circuit. That helps filter out other bits and pieces that occur inside a mixer device like that. The gain of the balanced modulator is set by a trim pot between pins 2 and 3. And the recommended position is 1K. You can vary it up and down and get quite a significant change in gain, but every time you touch that, the carrier balance shifts. So I prefer to just leave that around 1K. So here we're looking at the output of the microphone preamp at the terminal that feeds the balanced modulator. You'll see it's set around 200 millivolts peak to peak, and that is with the microphone gain control halfway. Now I can drop it all the way down to nothing, or I can wind it up quite high all the way up to around 584, nearly 600 millivolts, but I like to operate it about halfway. I might need to actually drop it back to there, just depending on what comes out of the balanced modulator. We'll leave it at 190 at the moment, or 200. And we've also set the microphone gain inside the microphone amplifier to match the tone. Like 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So that's hitting similar peaks. Again, I can vary the mic gain to go right down to nothing, or I can vary it so it goes up high like that. And we don't want to do that, so we just set it halfway, around there somewhere. So here is the balanced modulator, LM1496. Here's the output, and we are probing the input. So we have 2 channels running, and we have a couple of controls. That's the carrier balance or null. This one's the AM carrier level, This is the gain control. The gain control is set at 1K, and a tune circuit for the 9 megs. So this is the input signal from the microphone preamp. Wind that up and down. Set that at 200, maybe 200 millivolts thereabouts, and that's the output signal, which is around 300 millivolts peak to peak. You'll see it's actually double sideband signal. So here is a view on the analog crow. It does a better job of the balanced modulator output, unlike the digital crow, which triggers on just about anything. Here we have the output of a single tone out of a balanced modulator with no carrier. It'll have upper and lower sideband coming out of it, but no carrier. This is the incoming, this is the tone going in. And that's what you see on the digital crow, and if I try and take the time base any lower, it actually expands out, which is a bit of a nuisance, but that's what it does. So we can see the modulation envelope at that setting, which is 80 microseconds. So here we've set the BFO at around 200 millivolts peak to peak, so we'll use that as the figure going into the balanced modulator. And here is the output, which is around 100 millivolts peak to peak, maybe a bit more, the output of the balanced modulator with that tone going in. Turn the tone off. The top one is the BFO, of course. There we go. And that's the balanced modulator output on the fast Fourier transform. You can turn the tone off and on. That's off. So here I've tuned to 7.150 megs or thereabouts. That's what's actually coming out of the rig from after the balanced modulator is processed. And I'll just turn the tone on. And the S meter is reading around plus 30. I turn the tone off because I can up the tone level with the mic control, so I put it halfway. Now what we're listening for is the carrier. That's the thing that we need to adjust. And as I tune around, I can't hear anything. So I go back down near that frequency and I will unbalance the modulator. Turn the tone back on, so we're there. So now we're going to I've deliberately unbalanced it so you can hear the tone. There's the tone coming up, and tone going down. So how much suppression we've got? Well, we can have a look at the S meter for that. Let's have a look at that. So there's the signal with tone, and it's reading plus 30, S plus 30. We turn the tone off, just the tone, not the transmitter, and we see it's below S1. So if I unbalance it now, you should see it come up. There it is. So that's not too bad. There it is on the spectrum analyzer. So we just turn the tone off. A little bit there. So we can try and nail that. There it is. Very sensitive, this one. I can get it right down low. Somewhere down there. Turn the tone back on. We're looking at 10, 20, 30, 40, 50, 60, 70 dB. But the S meter is not a bad indicator. This is probably a bit more accurate. So we're looking at probably about a suppression of about 60 to at least 60 dB anyway. There's the two-tone signal. Of course, this is double sideband, so there are two sets of tones. So I drop the level, If I go too high on the mic drive, suddenly I get a lot of clipping. This is probably taking place possibly at the output of the balanced modulator, somewhere there. That's over halfway. It's about halfway there where I would normally operate it. So that's the single tone, that's the two tones. That's the AM mode with the tone, and without tone, the carrier. I'll go to AM, and now I can adjust the carrier level for that tone. That's the carrier level. That's not enough carrier, so you've got to try and get 100% modulation. Increasing the audio level. What we should do there is go back to sideband, so that we have what we would normally be the operating position, which is about halfway there. That's with one tone. Go back to AM and set the carrier somewhere around there. It's not a bad place to be, and then add the tone. Now that's too much, so we need to drop the audio level. Drop the audio level there. So it's probably too much. It's too much carrier, so we really need to drop the carrier so it looks about the same as with sideband. Maybe around there somewhere, and drop the audio level accordingly. So a little bit of a juggle. So on AM we need to tweak things a little bit. The mic gain has to come down for a given carrier level, but that's fairly normal. You use your instruments for that. About there somewhere. So I'm just going to test the AM with a bit of audio, just so you can hear that. 1, 2, 3, 4, 5, testing AM. I'll just turn that up a bit. Hello, test, 1, 2, 3. That's the AM signal. So this is some sideband. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I just tune the transmitter a bit, drop the levels slightly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hello, test, 1, 2, 3, 4, 5. Hello, testing. That's this rig here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hello, test. This is AM on this particular rig here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're coming out of the other homebrew. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hello, test. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Coming out of this rig on sideband. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.